All right. Welcome everyone to this week's presentation of the DBA Fundamentals Virtual Group. This week we have Porter Chaves talking about the intro to Azure Synapse Serverless Pool, which I know I'm looking forward to. As you can see, today's date is March 29th, 2022. In the top right-hand corner of the screen, you'll see the three leaders of the DBA Fundamentals Group, Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. To the right of each of our names is our Twitter handles, if for any reason you need to get hold of us. Further down the screen, you also can see the DBA Fundamentals Group's Twitter handle itself. If you need to get hold of us, that would probably be the best way that you can get hold of all of us real quick. Speaking of that section, as you see beneath our names, you'll see all the different kinds of social media we have for us. Obviously, the top one is Meetup, where probably most of you got hold of or accessed this presentation itself. Below that is our website, dbafund.org, where you can see all of our past presentations as well as our upcoming presentations. They're all out there for you. Below that is our version of YouTube, dbafundtube.com, where you can actually see all of our past presentations. Be sure to like us on there and subscribe to our channel, just so that you'll know when we actually are putting out all of our presentations. You'll be informed as quickly as possible, at least as fast as those little turtles can move. Below that is the Twitter handle, as I said earlier, DBA Fun, as well as our Slack channel and our LinkedIn group. With that, we'll talk about the recording, because today's session is actually being recorded, and it will usually be available within 1 or 2 days. As I said earlier, check out our channel on dbafundtube.com for all of our goodness. With that, please be sure to turn off your video and mute yourself, just so that we can have all the things actually based towards Warner till he can get moving and grooving. If you do have any questions, please be sure to type them into our chat. That feature is turned on, so you can have all kinds of fun and be able to read through and ask any questions you have. With that, we go to Warner. Here's his little bio on it. And with that, I turn it over to Warner.
Hello, everybody. So let me press share around here. 1 second. Share side. Let me know when you guys can see my PowerPoint.
We see it.
Okay, so thanks everybody for joining me today. We're going to do the intro to Azure Synapse SQL Serverless Pool. It is a pleasure to be here on the DBA Fundamentals group, which I've presented in the past before, and I love coming back to be able to bring in more people into our field and into more areas of our field all the time. Thanks as well, depending on where you are in the world. This could be your lunchtime, maybe this is your dinner time, whatever it is. Appreciate that you take 1 hour of your day to come and learn something with me. About myself, I've been a DBA consultant for 15 years. I used to work out of Hewlett-Packard in Costa Rica. I'm a solutions architect at Pythian. Pythian is based out of Ottawa, Ontario. I'm a Microsoft Data Platform MVP. Feel free to reach out to me on Twitter or LinkedIn. And you guys can check out also my personal blog. It's called createdatapros.com. If you think about something else as well, feel free to reach out to any of these ways, Twitter, LinkedIn, or email. Sometimes people have questions that they think about after the fact. And it's all good. Just I try to get back to everybody within a couple of days. And also my company employer, that's pythian.com. We do have a really big technical blog there as well that goes beyond just the Microsoft stack, goes into open source, big data, ML, Oracle, etc., etc. Cool. So today we're going to focus on the SQL Serverless Pool of Azure Synapse Analytics. So the goal is not to do a broad introduction to Azure Synapse Analytics, but to do more of a zoom into the SQL Serverless Pool. If you know nothing about Azure Synapse Analytics, I'm still going to cover just the basic bare bone fundamentals, and so you won't be lost. And then we'll just look specifically into the serverless pool capability. So I'll go over Synapse, high level overview. Then we'll go a little bit more in detail about the serverless pool. And then most of the hour we'll spend it doing the demos, right? So I only have about 9-10 slides, and then we'll go straight into the demos and how it looks in, real life. So what is Synapse? Just for the people that might not be familiar with it and they still decided to join us today. Synapse is, I say new service, but I mean I think Synapse was GA'd probably beginning of 2020. So it's been a couple of years now. But it bundles, the entire data engineering experience in one workflow. The idea is that you get, structured, unstructured capabilities, Spark, the SQL MPP pool, pipelines, um, data lake storage. It's all bundled and pre-integrated for you in one big service and one big workflow. And obviously, we'll use the Synapse workspace as part of our demo, so you get an idea of what it actually looks like. So the workspace is the one that's the concept that just encompasses all these other resources together, right? So we have, data lake storage Gen 2, we have Spark pools, if you need to run Spark against some of these of your data. We have SQL pools, which is further split into dedicated and serverless. And we'll go in detail on this particular piece, obviously, in this session. And then you also have the stuff that can be used for data integration, which is the same engine that is inside Azure Data Factory, but can be used to also create Synapse pipelines, right? So it's same look and feel, same components, etc. It just lives in a different place, and it's already pre-integrated with Synapse as well. And then I put Power BI there in the corner because it does have a strong integration with Power BI, but something that's very important, I always clarify, Synapse can work with any of the big third-party tools, is not exclusive to only working with Power BI. So you can have a client that is a big Tableau user, no roadblock. You can use Synapse to do your data warehousing analytics project and then hook up Tableau to it. Or I'm just using Tableau as an example, it could be Looker, Click, any of these modern data viz and analysis tools, they can all be used. It's not exclusive to Power BI. So as I mentioned before, zoom in on the SQL pools. So if you have obviously some SQL Server experience, this is most likely where you're going to gravitate to just using the SQL pools. The SQL pools are distributed versions of SQL Server. And for some of the veterans in the industry, this Microsoft used to sell this as an appliance on-prem. It used to be called the SQL Server Parallel Data Warehouse, and it got rebranded as the Microsoft Analytics Platform System. And with the advent of the cloud, I don't know anybody anymore that is doing these on premises. Most people are just going to the cloud for these type of projects, right? Because of the flexibility and scalability of the cloud. So you have these two concepts, and they're just at the end of the day, they're just like clusters under the scenes, clusters of machines of SQL servers. So the dedicated pool is a cluster that goes up and down when you start it or you pause it. And when it's up, you're paying for it. If it doesn't matter if nobody's running a query, if it's up, the cluster's up and ready to service queries, you're paying for it, okay? So you pay for the provision compute when it's up and running, and you pay for the storage permanently, right? So even if you pause the cluster, you still have storage underneath that cluster. You have to pay for that storage, right? So that's the dedicated pool. The cost of the storage is fairly economic compared to the cost of the compute of the cluster, right? And the compute of the cluster is elastic. So you could start with like 1/4 of a node and go all the way to, I don't know, like 60 nodes or something like that, right? Um, the other option for SQL pools is the serverless pool, and they're not exactly interchangeable in terms of their function. So what you would use the dedicated pool is not exactly today what you would use the serverless pool for. And I'll go a little bit in more detail there in the use case in just a couple of more slides. But the way they work are fundamentally different, right? So the serverless pool, there's no cluster that you size and then you bring it up and then you put it down. It's just always there. Microsoft has a pool of machines somewhere, and it's always that pool of machines is always ready to service queries. So you only use resources when you actually submit a query to the serverless pool. If you haven't run any queries against the serverless pool for the whole month, your bill for the serverless pool will just be literally zero, right? And the way that it's built is that you pay for the amount of data that you read, which is approximately about $5 dollars per 1 terabyte read. And this could be terabytes that um, let's say, for example, if instead of using CSV files, you're using Parquet files, and Parquet is a compressed format, then, maybe when you read 1 terabyte of Parquet files, it's actually more like, 2 terabytes of actual data. So if you use compression in your storage, then you get a benefit immediately, right? So per 1 terabyte of data that is read from the storage at the format that is stored in, right? So people that use compressed formats, again, like Parquet, for example, then they'll get benefits there. So serverless pool. Serverless pool only accesses data on the data lake storage. So this is the biggest difference from the dedicated pool. The dedicated pool has its own storage of SQL Server tables, right? The serverless pool uses data lake storage. So it's all about folders and files. And that's the way it works today. I don't know if maybe in the future Microsoft will make it so that the serverless pool will also be able to look into the tables that you created in the dedicated pool. But right now, it does not work that way. So it does not have access to the storage in the dedicated pool. If you were using the dedicated pool and you created like your own, let's say like a Kimball style star schema with dimensions and facts, and you loaded the fact table with bazillion records and column store indexes, it's all nice and good. It's great. Good job. But it will not be accessible from the serverless pool. Okay. It will not be accessible from the serverless pool. The serverless pool also doesn't have a way to define resource usage. You just send queries to it. And after that, the service does all the compute sizing automatically. And you don't pay for the compute sizing, remember? You just pay for the amount of data read. So that's something that today, to me, is kind of a limit in the system, is that if I have a particular query, and let's say it takes 30 seconds to complete. And to me, that's too long. Let's say I wanted to, finish in 15 seconds. I don't have a way to increase my cost as a trade-off for getting the response time down, which is what you get in the dedicated pool, for example, right? And if in the dedicated pool, I'm running in one node and it's taking 30 seconds, I have the choice of resizing my dedicated pool to 2 nodes and then cutting my runtime potentially in half, right? I don't have that option in the serverless pool. Okay, and this plays out into what the use case is for the serverless pool, right? So it's a compute service where you don't have a choice in how much compute you get. So whatever the query takes is whatever the query takes. Something else, because the data lake storage is the underlying storage of the serverless pool, then it does not support DML, okay? So you can't insert, update, or delete records because all it does is read or write from the data lake storage as files, okay? What you can do is set cost control limits, and I'll show you in the Synapse workspace in the panels there how we set that up. Very easy, so that at least because you're being charged by data read, you don't get some sort of crazy bill at the end of the month because somebody decided to set up some crazy process that is continuously doing serverless pool queries and is just racking up the cost, right? So there is a way to set up some limits so that there are at least no surprises in terms of how much you're billed for your use of the serverless pool. Now, this is an architecture of the serverless pool. This is lifted out of the Polaris white paper. Polaris is the project name that Microsoft used for this engine that they used underneath Synapse. And you can actually Google the Polaris white paper. It goes into very deep detail about all these components and how they were built. I just took like two or three different images from that white paper to just talk about what's happening behind the scenes, because I always find people um, like to learn some of these things, even though obviously we have no direct control over this. Um, this is always interesting. So, for example, what it does at the bottom says that there's a store abstraction called the data cells, and data cells can come from anywhere, right? So you can see here we have Azure Data Lake Storage, we have Parquet files, And then there's also these transactional stores like Cosmos DB. Now, if you follow Synapse, you know there's already a feature called Synapse Link that allows you to do Cosmos DB data, query it from Synapse Analytics. So that's part of this. Socrates, I think I believe that was the project name of the Azure SQL DB Hyperscale. um, I'm not sure if Azure SQL DB Synapse Link is already in preview or not, but I'm pretty sure they're working on it at this point. It's just a no-brainer, obviously, to be able to transparently query Azure SQL DBs from your Synapse pools as well. There is if you're familiar with the latest stuff that Microsoft announced for SQL Server 2022, there will be the ability to set up Synapse links to on-prem SQL Server 2022. So that's pretty cool. So all that, anywhere the data is coming from, gets translated into this concept of data cells, right? And then these data cells all get hashed so that basically the data itself gets bucketized, and then it gets distributed to the different machines that are part of the computation. Okay, and this is where it says the Polaris pool. Now, if we go into deep into what the Polaris pool actually is, then you can see here in this diagram, right? So we have the data cells here at the bottom, and then we go in, and then you can see each Polaris pool has a SQL Server front end that will submit the query to a distributed query processor, and then that distributed query processor talks to these different compute servers. And you can see inside each compute server, there's a cache, there's a SQL server, and execution service that is used to coordinate the work between all of them, right? And then there's multiple Polaris pools, right? So Microsoft probably under the scenes, they have, I don't know how many thousands of Synapse clients. They have many of these Polaris pools running so that whenever you submit a query to the serverless pool, they can service it almost immediately. And you can get your results back, even though there's not like just a dedicated cluster for it, right? It's all serverless. And you can see at the top, obviously, there's some centralized services for when you're working with the service, right? So the cool thing about this architecture, right, is that it enables a bunch of different scenarios, right? So you can do auto scale, right? So if the software fabric determines that some of these are too busy, right? So it can add more compute servers to it and then split off the tasks. So here, we go from 4 compute servers to 8 compute servers, and each one is now handling half of the workload. Also, the service can handle failures, right? So if we were doing a task with 4 compute servers and one of them goes down, then those 4 tasks can get redistributed to the other compute servers that are still part of this process without having to interrupt and restart the process. And it can also apply the same logic to hotspots, right? So if 4 compute servers are working on your query, and then one of them is getting really hot, then the service can rebalance. Even though it's not an outright failure, the service can rebalance some of the work. So in this case, for example, a couple of tasks were moved to these other compute servers, and then the one that was hot was left with just a couple of tasks, and it has more breathing room to do the computation more efficiently, right? So these are all cool properties of the architecture and the way that it was built that allows us to have these capabilities behind the scenes, okay? So in my opinion, because of the limitations that I just mentioned, right, it only communicates with data lake storage, there's no DML, there is no way to increase the compute power for it, then for me, the serverless pool right now is for exploration or ad hoc analysis in terms of, the end user. And if you want to use it for transformations or for reports, I think it's doable, but they have to be transformations or reports that are not sensitive to latency, right? So what I mean by that is that if you have some sort of transformation or report that always has to take the same amount of time, then this is not a good fit, right? Because you don't have any control over how long a specific task is going to take. And you can't say like, I want it to take exactly this amount of time, or I'm willing to pay for, double the regular compute to get it in half the time or anything like that, right? Maybe that's the direction that we will go eventually. For example, if some of you are familiar with Google BigQuery, which also charges you $5 per terabyte per query, exact same cost. Google BigQuery, if you want to have more compute, you're able to say, okay, Google, just charge me $10 per terabyte for this query, and then I'll get double the compute power for it, right? So maybe eventually it will move in that direction, but for now, it's completely automatic, and you don't have any knobs to get more compute power. Okay, so like I said, if you just do an exploration and analysis, you want to give something to your data scientists, to your data analysts, and they don't even know exactly what type of queries they're going to run. They just want to have an easy, low cost way to browse and query through SQL all the data in your data lake. Then Serverless Pool is a great option. And if you do have some transformations or reports, as long as they're not sensitive to latency. So let's say you have the whole night to compute them, and that's great. You use Serverless Pool, so you do the work very cheap, just by the amount of data read. The minute the query is done, you stop getting billed for compute, and that's it, right? And you had the whole night to compute it, and it's going to take, let's say, 15 minutes, but hey, you have 8 hours for those 15 minutes to be done, then perfect. It's a good fit for the serverless pool. If you need, on the other hand, enterprise reporting that you're going to hook up interactively to Power BI, has to be as responsive as possible, then right now this is not the place where you want to put the data or architect your solution. Okay, in those cases, that's what the dedicated pool is for. You have dedicated resources in a cluster that you size. You use SQL Server tables, you put column store on them, you make them super responsive, etc., etc. Okay, and that's it I have for in terms of theory. Let's just jump into the demo. What does Synapse actually look like, and how does this all matches up together? So for those that you're not familiar with it, this is the Synapse workspace, right? So you have a bunch of different categories here on the side. There's data, develop, integrate, monitor, and manage. So if you go to data, you're able to browse different data components that you have in your Synapse workspace. I'm just going to do it real quick so everybody can see kind of how it works. Um, Let me refresh this to get the latest stuff I already have. I was working on this earlier today. All right, so here we go. For example, Synapse Workspace, we have this demos database, and you can see here the tooltip. It says this database can be used with the serverless SQL pool. Okay, so it is a database. You can create views on it, for example, um, but and external tables, so you can query data through the data lake through table names. But again, you do not have the capability of inserting into those tables. Everything just lives on the data lake, right? On the other hand, for example, I have this one called SQL DW, and this one says it can be used with dedicated SQL pool, right? So this looks and feels just like a regular SQL Server database. You create tables on it, you insert, merge, update, delete, whatever you want to, right? Um, so that's the difference. Very different use case for them as well today. And then you have this lake database, which are basically databases that exist that were created through the Spark pool inside Synapse. Okay. There's also linked data, which is, let's say you have an Azure Cosmos DB, you have multiple storage accounts, etc., etc. Okay, so that's data. Then there's develop, where you have all the artifacts that you can store inside the workspace: Power Query transformations, SQL scripts, notebooks, data flows, or Power BI reports. There's integrate, where you can create data pipelines. You can see I have a bunch here already pre-created as well. I'm not going to go into that topic for today. Monitoring, where you can see everything that's happening inside your Synapse workspace, right? And manage, where you see all the different components and configurations of your Synapse workspace. I did not mention this component in the slides. This is fairly new. This is a Data Explorer pool. This is in preview right now. I'm just going to mention it right now since it's on the screen. And it is basically a new engine built into Synapse to handle time series analytic data. Okay, so it's more for like streaming time series data, similar to like what Microsoft actually uses for the metrics in the Azure portal. Okay, and you can see here, for example, here's the two SQL pools. You see the serverless one says built in, and the size, it just says auto. You can't really pick a size, right? So if I go to the dedicated one, I'm not going to resume it, but let's say I wanted to create a new one. you guys can see here, I can pick the size, right? So I can go from, $20 an hour. If I crank it up all the way to DW 30,000, I don't even know how many nodes that is, but that would be, 600 Canadian dollars an hour, which is like, I don't know, 500 US. So that's the big difference, right? I can resize, bring down the dedicated pool, the serverless pool. It's all automatic, right? And it's always up and running, right? And right now, my dedicated one, for example, I have it paused so I don't get charged for compute. This just serverless, okay? And that's pretty much how the Synapse workspace operates. I go back to develop. We'll go back to my script for today. And let's just run down. I want to run down some of the capabilities of the serverless pool and how it works in general, right? So one of the main things that Microsoft did for serverless pool is that they augmented the OPENROWSET function to really work well with Azure Data Lake. So OPENROWSET is not a new function. It has existed in the past. It exists on SQL Server on premises for a very long time. And what it does is that it goes and reads data either from another database or from storage and then brings it in as the tabular format for SQL Server, right? So what they did was build it or recode it in a way that works really easily with data lake storage, fully integrated. So you can see, for example, here, I have a select top 100 star. So I'm not specifying column names or anything. I'm just going to run it. I'm not specifying column names, schemas, nothing for this particular query. I'm just saying, look, just give me the top 100 records, whatever you find from this file, right? And you guys can see here, the results are right there. So I just have to give it the URL of the file. And all I had to do behind the scenes is that the Synapse workspace has an identity in Azure Active Directory, and I gave that identity read access to this storage account, the Warner Data Lake, okay? Once I do that, and then the Synapse workspace is able to read data from there, I don't even have to specify schema. I just say, hey, bring me everything from this Parquet file. This is the format, and then boom. So you guys can see how it's really easy for exploration and analysis, because let's say I'm trying to do some exploration of all the files we have in our data lake. Well, if I have to know the schema of the file before I read it, then that kind of defeats the whole ease of exploration thing, right? Like, and then I have to actually open the file and inspect it before I know how to query it. So this is something that's pretty neat, right? We don't have to specify any schema. We just go ahead, query it. You can do an absolute one, or you can even query through a relative path. So you guys see here, I'm going to run it again. And this is the exact same file, but now it's being queried through a relative path. So this is just an quality of life kind of thing where the serverless pool can query the account that is being used for the Synapse workspace with just a relative path. So it makes a lot of things easier. You don't have to be copy pasting this big giant URL every single time. You can just create a data source that is already pointed at here, and then you can use relative paths from then on, right? So it makes the queries a lot more readable in that sense, right? The database itself, keep in mind, even though it's serverless, it is a database. So for example, it has properties similar to a SQL Server database. In this case, I'm just looking at the collation it has, for example. You can see that if you wanted to, you can even alter the collation of that database. It is a real under the covers database. It just doesn't allow you to create SQL Server storage tables, for example. All you can do is create external tables that point to the data lake storage. Reset that back. If you want to know, like I said before, you can run a query and let SQL Server figure out the column names and the schema of the data types of those columns. But then how do you know what SQL Server is kind of doing behind the scenes, right? So you can actually do a call this stored procedure that allows you to describe the result set. So I'm going to run that now. And what it does is it tells you, well, okay, so I found if you run this query, this is the schema that you're going to get back for your results, right? You're going to get the artist name, this rate. These are going to be the types that we're going to infer. Notice here, for example, in the case of strings, parquets don't have a string length. So in the absence of any other data, then these always get inferred as being the max size for a varchar, right, which is 8,000 characters. All right. If you wanted to, you have the freedom of specifying better data types, for example. So you can see here, for example, here I'm saying, okay, do the same thing, but with the artist name making it a specific length, 100, and a specific collation, for example. You can even do that. And then behind the scenes, the serverless pool will do those conversions when it runs. You can see here, I can run this, and no issues with the result, and I get exactly the columns that I asked for. So something here, somebody might say, okay, well, why do I need to do this if it works the other way without specifying anything? So I haven't run into this issue, but I've spoken to other MVPs, and some of them told me as a general recommendation that when they started to actually doing work with the serverless pool with hundreds of gigs of data, the difference between just letting the system figure out the schema or you specifying the actual sizes, especially for the strings, it started to make a difference in the runtime, and it was most likely their hypothesis is that it's most likely because the engine itself reserves some memory or some buffers based on what it thinks is going to come in. So there's better use of memory if you specify the actual lengths that are there in your data, if you know them. If not, then you can always just go with automatic inference of the schema, right? That doesn't work just with Parquet. You can work with the limited text as well. In this case, I'm using CSVs, but it doesn't have to be a comma, for example. It could be something else. It could be delimited by tabs. It could be delimited by pipes, etc., etc. And you see here, for example, I have format CSV, and it says parser version 2.0, and I'll talk just really briefly about what the difference is. Now, you notice here, very cool as well, even for CSVs, I don't have to specify the schema. It just figures it out, right? It just said, give me one, top one, and it read the header and gave me the data there. So if you're using the 2.0 version of the parser, which is the latest version, you don't have to specify the schema. Okay. Now there's still availability for the 1.0 version of the parser. And the reason for that is that this parser supports gzip compression, which the 2.0 parser does not support yet. Okay, so that's why there's still both versions of the parser are available. However, if you use the 1.0 version, because you have some gzip text files, you do have to specify the schema. The 1.0 parser does not do schema inference. So you have to specify what is supposed to be being read from that CSV file. However, once it's set up, it just works just the same. Okay, so just keep that in mind. There's a couple of different versions of CSV parsing, depending on what you're trying to do. Okay. And if you do have files that are gzip, that are just text delimited, you don't have to uncompress them all as long as you're using the 1.0 parser. For JSON, it works really well because it just uses, again, SQL Server behind the scenes. So all the support that Microsoft added to SQL Server, starting from SQL Server 2016, it's all built in there already, right? So JSON is already there. You guys can see here, for example, I can say OPENROWSET to a JSON file and just pass in this invalid character as the field terminator. So everything gets read into a variable. I'll show you guys what that looks like. So if I run this, basically what I'm going to get is just the entire JSON has been pulled into the result set, right? So it's good to read the JSON, but it's not really useful, right? But as I said before, we can just leverage the stuff that Microsoft has already developed and start to work through massage that JSON to produce the result, right? So in this case, we see here, I have this cross-apply open JSON. I'm going to run it. And with this open JSON function, if you were doing JSON work with SQL Server on-prem, is the exact same function, right? It allows you to grab that JSON and start to split it into different components. So you see here, for example, I applied that open JSON, and now I have every record, but they're still like JSON format. But at least now I have them all split. It's not just one massive JSON file. What you do there, if you're familiar with OpenJSON, then This is not going to be something that you haven't seen, but if you're not, then basically what happens is you use this OpenJSON function to continually decompose the contents of the JSON up until the point where you're happy with it, right? So you guys can see here, I can apply the OpenJSON again to this value column, right? And then you guys will see what it looks like. That. And you see now we split it up yet again one more level, but it's kind of unpivoted, right? So instead of having these column names like user ID, gender, age, country as top columns, we still have key, value, type as the columns, and this is unpivoted right now, right? So this is not exactly what we want, but it's very easy to switch, right? So what we do is we have to specify the actual columns that we want from that value column. You see here, open JSON, apply it again to this value. But now I'm going to say with these columns as the output. Okay, and that's finally going to give us the representation that, you know, most people would want to get out of a JSON file when they're reading it, right? Which is usually some sort of tabular format, right? So just to give you an idea here. So that's how we started with just a massive JSON string. You decompose it through OpenJSON, end up with, nice tabular representation. Very easy to do with a serverless pool because of the JSON capabilities that Microsoft has already built in. Now, a big thing that comes up all the time as well is that inside Parquet, you can also have embedded JSON. For example, there's no issue there as well. For example, I have this sample file. You see here's a Parquet file. It has a user ID. And then the second column is just a chunk of JSON associated with that user ID. So no big deal. You can get to it as well using the same technique, applying the OpenJSON to that property of the Parquet file called JSON props and specifying the columns that you want to see. And if you specify the columns, you'll see you'll be able to even right away in the where clause filter through so that the serverless pool can apply the filter inline as well as it's decomposing the Parquet file. And you see here we get the tour results from Germany, right? So that's pretty neat as well. Full support for that as well. Okay. Now, something that comes up all the time, I'm going to put it right here, highlighted. It says, people ask me all the time, what about XML? Well, the answer there, which most people don't like, but it is what it is, c'est la vie, is there is none really. So for, I don't know what technical engineering reason, Microsoft did not port over the .NET based data types that SQL Server has. So if you are familiar with SQL Server for a very long time, you'll remember that XML, I think there's another data type called hierarchy, and I think the geospatial data types were all implemented through .NET. They're not like implemented core inside the C++ of SQL Server. So whatever technical engineering reason Microsoft had, they did not bring those over. So what does that mean? It means that if I want, I can read an XML file as a massive string and load it into either the dedicated pool or the serverless pool. But once I have it like that as a varchar, like a really long varchar, I have no way to parse it. So not really useful in my opinion, right? Because then you would have to like basically rewrite your own XML parser. That makes no sense. So the recommendation right now is if you are going to work with XML in Synapse, then you're just going to have to use Spark to work with the XML, okay? And in Spark, if you're familiar with Spark, Spark has full support for Scala, Java, Python, and any of those languages has XML libraries that you can use to do all the parsing. And what I recommend to people architecturally is that if you do have a bunch of XML files, XML in general, if you're doing it for analytics, most likely you're going to pull out some fields and then not really want to touch the raw XML ever again. So you can do something like a Spark transformation where you extract data from the XML and then you write it back into data lake storage as Parquet files that have a structure that you want with the fields that you want to get out of the XML. And once it's in the Parquet compressed format, then you just use them for your serverless pool analysis. Okay, so that's my recommendation if you do have a lot of XML. If you don't, great, it does support it anyway. So let's say the other way that you can also communicate with the serverless pool that is not through OpenRowset is by creating external tables. Okay, I already created this, but I'll run through it. So for example, you say, okay, I want to create an external table. This is the name. These are the columns that I want. And this table, this external table, is basically just like a pointer to this location in the data lake. But when I give access to analysts or data scientists or anybody else to my serverless pool, they can query that external table and selects without having to put all the open row set stuff, right? They don't even have to know where that data is actually sitting on. So if you already know about some particular folders or files that will be used by people for analysis, you can proactively create external tables for them and isolate them from the underlying information of your data lake, right? So you can do that very easily. And then once you have external tables, for example, you can create views on top of those external tables to provide even more levels of abstraction, right? So for example, here, I'm just doing a top 10 from full artist profile. You see, I get the result, no problem. And that's basically doing a view over an external table over a Parquet file, right? So different ways that you can structure, or you can maybe give people access to create their own views, but not their own external tables and stuff like that, right? It's really up to you. And if you have the result of a serverless query that you want to save into storage, then you do the opposite. So you do a create external table with, and you give it the location where you want that external table to go, and you say as you give it the query, right? So in this case, when I run this, what the serverless pool is going to do is it's going to compute this query, and it's going to place the results of this computation in this path and create an external table that is going to be pointing to this path. And I have my Azure Storage Explorer open here, so we can see the path is music data and full artist profile, 2020, November. And you see here I have one Parquet file with just a GUID name on it, right? So automatically the serverless pool created this Parquet file in this location, and it created this external table that is now pointing at this location. And I don't have to know, for example, the exact name of that Parquet file. It doesn't matter. And after I can just go in and query this external table, and it'll give me the data that is sitting there in that particular folder. And you can notice here, I could do the same. Let's say if I wanted just data for December, if I wanted data, split it into, let's say 2021, January, etc. And this is a very common way of partitioning stuff on data lake. Usually, if you're going to be working on a data lake project, you want to partition your data by time, because time is by far the number one predicate that people use to analyze data, right? They'll say, I want to query these columns from these tables, and there's 99% of the times there's a where clause that says where the time was, last year or last month or last month on Tuesday, etc., etc. So I usually recommend people do. In this case, I did it monthly just because we're doing demos. But most people that are working on analytics projects, they do maybe daily loads. So there, you would do something like 2021 month, day. Um, so we will have, let's say 01 here. If you were doing more than daily, you could do even further than that, right? You could do something like day, folder, hour, and usually I leave it around that. If you go all the way down to minute, well, that would be if you're getting like a really steady stream of files every minute, almost like a micro batch scenario, then I guess maybe you want to go down to minute. But for the most part, I'm okay with leaving it to day or hour. Okay. Um, and then there is a little bit of cool tooling, right? If you use this type of partitioning, right? Time-based partitioning. So I can do select count all the records that are from 2020 November, right? So there's 676 records in that Parquet file. If I want to see everything that is from 2020, notice this is going to fail, actually. I'm just putting the folder, but I'm not specifying anything after the folder. This is going to throw me an error. It says, no, I didn't find anything there, any actual data there. The reason is because, you know, if you go to 2020, there isn't actual data there. It's folders, right? But it does support star wildcards. So if I say 2020 star all folders, another star all files, then it's going to be able to go in it and it's going to count them properly. So you see here I have double, right? 676 times 2 because I have the 2 folders. I have December and November. And you can put the wildcards at different levels. So for example, I can put the wildcard in the year part of the path. So if let's say I had multiple years and I want to query Novembers of different years, I could do that. That works. This works just fine right now. You get the same data, right? 676. And you can also have some of the metadata from the rows that you're reading. So here you can see I have this, I'm using this file name function, and it actually tells you what are the files that is reading when you're applying that wildcard, right? So you see here I have the file name and how many rows were read from that particular file, okay? So if you're ever wondering, you know, I wonder in this query that I have, what is the actual file underline that I'm getting from it, that I'm getting the data from, then you can do these, use these type of like helper functions, file name. You can even decompose the path. You can see here where I have file path 1, file path 2, and these will replace, give you the values of the stars. So it makes sense here. I have full artist profile, star, star, and I know the first star will be the year. So I say file path 1 is the year, file path 2 is the month, and I can mix it into my query as well. And I'm doing a count star here, for example. So I know, right? So this is basically giving me information of the path as well that I can mix in into the rest of the query too, right? So this is pretty neat. And the cool thing about this is that you can also use them for filtering, right? So I can say where the file path 1 is 2020. So that allows me to run a serverless query that goes into a specific place in the data lake. A big mistake that people make is that just because it's automatic serverless compute, they make one folder and then they stuff one folder full of data, and then they complain that the serverless pool is really slow. And of course, it's going to be really slow if you do it that way because you don't give it any sort of information about where it's supposed to go, right? So it just has to scan everything. So you always want to have some sort of structured folder partitioning strategy so that you can use this in your predicates and you only go to the folders and the files specifically that you want to target. All right. Okay, well, I guess that was it for, oh, one thing that I did forget now that I think about it is I want to show the cost controls for the serverless pool. So if I go to the serverless pool here, it's in the manage SQL pools. You go to the built-in pool, there's a little dollar icon there with a gear right here, and you can press it. And you'll see here I have my cost control. And you'll see here, for example, it says data processed today, 356 megs. That's literally just, you know, the demos that I've been doing today and setting up for today. And I don't have anything set up as limits, but we can see here the different limits that we can put in. You can put in a daily limit, a weekly limit, or a monthly limit. And that way, if anybody hits any of these limits, you can actually set it up so that you will get notified as an admin of the Synapse workspace, and it will not allow any more compute to happen. So if I have a daily limit and it hits the daily limit, then it's not going to allow any more compute until, you know, 24 hours have passed. Same thing with the weekly or monthly, right? So if, you know, we're in the 29th of the month and you hit your monthly limit, then it will not allow you to do any more compute until April 1st rolls in. Okay. All right, so let's head back into my slides and just a quick recap. So the serverless pool, as I said, I think is a great fit for low-cost exploration or transformation or reports that are not sensitive to latency. It is not a replacement for the dedicated pool yet, again, because it doesn't have dedicated resources. So you can't really control exactly what it's doing behind the scenes. It doesn't show you execution plans. You can add hints or try to do stuff like that. The best you can do is create compressed files and make sure you have a good folder structure so that you can target the specific file, specific folders of the data lake in your queries. The access is you can do it through external views and then you can, external tables, and then you can build views on top of them if you want to. Or if you just want to do purely ad hoc analysis of stuff, then OpenRowset has been extended quite a bit so that you can use it for just exploration. And in my opinion, very promising to see how Microsoft continues to grow the serverless pool, because I think it does fit a very important niche of people that want to do analysis, they want to do exploration, they want to do experiments, so on, in a low-cost way where they're not looking for a dedicated cluster that's always up and running, or that they have to bring up and then they have to pay for the compute, even though it's not really doing anything. So I do think it fits a good niche, and it just needs a couple of options, maybe a way to add more compute power if you want it. A way to see an execution plan would also be nice to see if you're not getting good filtering and stuff like that. And I think that would really improve the service in the future. And again, this is Synapse is Microsoft's flagship analytics service in the cloud. So I am pretty sure they're working on a lot of these things as well. All right, so let's take a break here and see if anybody has any questions.
We do have some. First one, for the dedicated SQL pool, do we have the ability to auto resume and auto stop?
Nope, that's another issue.
That was the easiest question.
Yeah,
Nope.
it's that's like request number one. I'm 100% Microsoft is working on it. People ask for it all the time. Right now, the best they have is there's a sample online for like a cloud function that is waits to see if nobody's running anything for X amount of minutes, then it shuts down the thing. So auto shutdown is easy, but how do you bring it back up, right? That's the tricky part. So it's a half solution. Um, so the full answer is basically it's in progress, but no, it doesn't do that today. If it was, it would be a lot more attractive. It would kind of like defeat, in a way, not defeat the purpose of the serverless pool, but it would make it that it would be harder to choose between the two of them, right? Right now, the way that the dedicated pool works, it doesn't do it, so it's definitely not as attractive for just ad hoc exploration.
All right. Next question. Are you aware of any other Azure tools that are able to open Parquet files in ADSL apart from Synapse Studio?
Well, you can run Spark in many different ways, and obviously you can do any sort of storage file-based computation with Spark, right? So you can use the Spark in Synapse. If you don't like Spark in Synapse, you can use Databricks. You can use HD Insight. I wouldn't recommend it though, right? It's too much work for just that. Nowadays, I think Microsoft actually extended Azure SQL DB. So if you just want to read some Parquet files, you could do it even with Azure SQL DB. It's obviously not going to be as powerful. It doesn't give you all the analytic capabilities of Synapse, but if it's something small, you can use Azure SQL DB for that. You can even do a serverless Azure SQL DB if you wanted to. Might be a little bit slow, but depends on what you're trying to do, how much money you want to spend. There's definitely a lot of options.
As always. All right. So that actually seems like the last of our questions.
Yeah, all right, sounds good. I appreciate it, everybody. Thanks for the time. Thanks for joining. And hopefully we'll have some new material. Always working and thinking on something new and bring it over here.
Yep. Perfect. We thank you so much, Warner, for that. All right. So with that, thanks everyone for joining us for this week's presentation. Next, let's see, our next presentation will be on April 12th with storing and searching files in SQL Server file tables with Sam Nasser. And yes, remind everyone that yes, today's presentation has been recorded. It will be on our YouTube channel here shortly, probably within the next couple of days. So with that, we do thank you all so much. And with that, have a great week, and we will talk to y'all next time.
Great day, everybody. Thank you. Bye.